What if your AI image editor didn't just change pixels, but actually understood physics? What if it knew that when you pick up a coffee cup, the shadows change, the hand grips naturally, and the liquid inside responds to motion? Welcome back to the channel. Today we're diving into NVIDIA's ChronoEdit, a groundbreaking image editing model that's completely rewriting the rules of AI-powered image manipulation. This isn't just another incremental update. This is a fundamental reimagining of how AI thinks about editing images. Whether you're a content creator, AI enthusiast, or just someone fascinated by cutting-edge technology, you're going to want to stick around for this one. Let's get into it. So what exactly is ChronoEdit? At its core, ChronoEdit is a foundation model that treats image editing as a video generation task rather than a traditional image-to-image transformation. I know that sounds a bit abstract, so let me break it down. Traditional image editors, even AI-powered ones, typically work by taking an input image and directly generating an edited output. They might be great at adding objects or changing colors, but they often struggle with something crucial: physical consistency. They don't really understand how objects interact with the world. ChronoEdit takes your original image and your desired edited image and treats them as the first and last frames of a video. This allows it to leverage massive pre-trained video generation models that have learned the implicit physics of how objects move, interact, and exist in space over time. But here's where it gets really interesting. ChronoEdit introduces something called temporal reasoning tokens, essentially intermediate frames that represent the logical progression from your original to your edited image. Think of these as the model's way of thinking through the edit. When you ask it to add sunglasses to a cat's face, it doesn't just slap them on. It imagines the trajectory. How would those sunglasses naturally appear on that face? How do the shadows change? How does the geometry work? The model is literally reasoning about the physical transformation before committing to the final edit. And here's the cool part. You can actually visualize this reasoning process. The model can show you the intermediate frames it considered, giving you transparency into how it arrived at its editing decision. Now let's talk about what makes ChronoEdit so impressive compared to previous models. There are three major innovations here. ChronoEdit produces edits that follow physical consistency, which is especially critical for physical AI applications like autonomous vehicles and humanoid robotics. When you edit an image of a robot arm picking up an object, ChronoEdit ensures the grip is natural, the object's weight appears realistic, and the surrounding environment responds appropriately. Previous models would often create physically impossible or uncanny valley results. The model separates inference into a video reasoning stage for latent trajectory denoising, followed by an in-context editing stage that prunes those trajectory tokens. This is computationally smart. It only uses the thinking phase when necessary, then discards those intermediate tokens to avoid the massive computational cost of rendering full videos. The system found that using reasoning for just 50 sampling steps achieves performance comparable to reasoning across the full trajectory, making it much more efficient. ChronoEdit distills knowledge from a 14 billion parameter pre-trained video generative model, meaning it benefits from the vast understanding of temporal dynamics and motion patterns learned from enormous video datasets. This gives it an inherent understanding of how the world works that flat image models simply can't match. And the results speak for themselves. On benchmark tests, ChronoEdit 14B matched or outperformed the 20B parameter Qwen image model across all tasks, achieving particularly strong results on challenging categories like background changes and action motion edits. Even more impressive? ChronoEdit 14B Turbo runs 6 times faster than the full model, 5 seconds versus 30 seconds per image, while achieving results only 0.3 points below the full model's performance. That's the kind of efficiency that makes this technology actually practical for real-world use. Okay, so why should you care about all this? What are the real-world implications? Imagine editing product photos where the lighting, shadows, and reflections automatically stay consistent, no matter what changes you make. No more painstaking manual touch-ups. ChronoEdit understands how light works in three-dimensional space. This is huge for autonomous vehicles and robotics. ChronoEdit enables action-conditioned world simulation. You can generate training data that shows physically accurate scenarios. What happens when a self-driving car makes a U-turn? How does a robot arm manipulate different objects? ChronoEdit can generate realistic variations of these scenarios for training AI systems, without the need for expensive real-world data collection. Game developers and filmmakers can use ChronoEdit to create physically consistent variations of scenes, character actions, and environmental changes. The temporal reasoning ensures that everything feels grounded in reality, even in fantastical settings. Scientists and educators can visualize physical processes and transformations in ways that were previously difficult or impossible. Show the progression of an experiment, the movement of mechanical systems, or the interaction of objects, all with physical accuracy. And here's what really excites me. NVIDIA has released ChronoEdit as an open-source model with both 14B and smaller 2B parameter variants available on HuggingFace. They've provided the full training infrastructure, inference code, and even LoRa fine-tuning capabilities. This means researchers and developers can actually build on this technology, adapt it for specific use cases, and push the boundaries even further. The model is available under the NVIDIA Open Model license, which allows for commercial use. So this isn't just a research toy. This is production-ready technology. So, there you have it. NVIDIA's ChronoEdit, a model that doesn't just edit images, but understands the physics behind them. By reframing image editing as a video generation task and introducing temporal reasoning, NVIDIA has created something that bridges the gap between visual editing and physical understanding. This is the kind of technology that's going to fundamentally change how we interact with AI image tools. We're moving from make this look different to make this behave realistically, and that's incredibly powerful. If you found this video helpful, make sure to hit that like button and subscribe for more deep dives into cutting-edge AI technology. Have you tried ChronoEdit yet? What would you use physics-aware image editing for? Let me know in the comments below. The links to NVIDIA's research page, the HuggingFace model, and the GitHub repository are in the description if you want to try this yourself. Thanks for watching, and I'll see you in the next one.